Welcome to Thriving Academy. Into this class, we'll be looking at system of solving linear equations involving three unknowns. We all know linear equations, right? We have simultaneous linear equation, which we have two methods of solving. One of the methods is elimination method, and the other one is substitution method. Now let's look at the one involving three unknowns. You know that simultaneous equation involve equations that have how many unknowns? Two number of unknowns and two equations. Now, so linear equation that have three unknowns has three equations. So you are going to look for the value of the first unknown, A, and one of the first unknown, value of the second unknown, and the value of the third unknown. Now, when solving simultaneous linear equations that have three unknowns, there are 4 to 6 methods. So the first method is method 1 is we have the Gauss elimination method. All right, we have Jacobi integration method. C, we have the LOU decomposition method. D, we have Gauss-Jordan method. Then as time goes in, there's any other method. We have a Gauss-Sedan as this. All right, as time goes on, there's still any other method. I'm going to include it. Now in this class, we'll be looking at the Gauss elimination method. We have the Jacobi's integration method. I'm going to look at this. I'm going to look at LOU decomposition method. We're going to look at Gauss-Jordan method. I think we still have the inverse method. So we are still going to look at the inverse method. In today's class, we'll be looking at the Gauss elimination method. Just as the name implies, Gauss elimination method is just like the normal elimination method of solving simultaneous equation. Just that this type of equation now we'll be looking at three unknowns. So the Gauss elimination method, we are going to use the elimination method just like the way we have been using it to solve simultaneous equation. And let's look at, remember that linear equation involving three unknowns are in their form A1, let's say A1x1 plus B plus A2 plus let's say A2x2 plus A3x3 equal to B1. Then A1, let's call this A11, let's call this A12, all right? Let's call this A13, let's call this B1. Now this will now be A21 x1 plus A22 x2 plus A23 x3 equal to B2. Then you have A31 x1 plus A32 x2 plus A33 x3 equal to B3. Now remember that our unknowns, linear equation of three unknowns, is in this form, where we will be asked to find the value of x1, x2, and the value of what? X3. You get me? Remember, is this A11, A12, A13, A21, A22, A23, A31, A32, and A33 all are what? Constants. Remember, it will not be, they will not use A11 and A12, all these A's, to denote the constant. In real life, maybe when you are solving, you might have something like this, maybe 2x1 plus 3x2 minus x3 equal to 7, 4x1 minus s2 plus 2s3 equal to 5. X1 minus s2 plus 7s3, all right, equal to 17. This is how it looks like. I just use the A11 now to represent the constant that will be there. Then B1 represent the other words, equal to sign. All right. So while solving with the gas elimination method is very easy. All you have to do now is to form this equation, represent this equation in matrix. How do you represent this equation in matrix? It becomes, let's call this equation 1, call this equation 2, and call this equation 3. Now let's represent equation 1, equation 2, and equation 3 in matrix. All right. So representing equation 1, 2, and 3 in matrix, it becomes A11, A12, A13, A21, A22, A23, A31, A32, A33. Close the bracket. Then you have x1, x2, x3 equal to, remember, is equal to b1, b2, and b3. So here will be equal to b1, b2, and b3. So if you represent equation 1, equation 2, and equation 3 in matrix form, you are going to what? Get this. Now, our aim of the gas elimination method is to reduce this matrix here to form an upper triangle, a matrix that will be in the form A11, A12, A13. Then here will not be maybe A21, A22, A23. Then here will be A33. Such that this point here will be 0. Now, our aim here is to reduce this particular matrix to this form, such as we are going to eliminate x1 from here. If we eliminate x1 from here now, this particular point of x1 will become 0. We are going to eliminate x1 from here, eliminate 2 from here. If we eliminate x1 and x2 from equation 3, this point here becomes what? 0. So our aim is to get this triangle, upper triangle of what? Of values. That is the aim of this gas elimination method. Once we are able to get this upper triangle of value, all right, we will be able to solve for x3, because here now x3 will now have a coefficient here that will be equated to this. So our aim is to get this. All right. Now let's look at how to get the upper triangular matrix that I showed you. This particular matrix, A11, A12, A13, A21, A22, A23, and A33. Let's say A23 prime, because this one I use prime and prime here is because while we are trying to eliminate 0, eliminate S1, S2 from this particular equation, our value of A2 and A3 and A31 and A32 and these are changing. The same thing applicable to the values of B's, right? While we are trying to do the elimination, the value of B1, B2, and B3 are what? Changing. That's why I replace with prime and what? Prime here. All right? Now let's see how we can get 0 here and get 0 here. To get 0, this lower triangle of 0, or to get this upper triangle of values, is very easy. Let's see how we can eliminate this if we are going to get 0. Now let's go. Now from equation 1, if we eliminate S1, from this equation, we are going to get 0 here. How do you perform the elimination? Now let's look at step 1. Step 1 of performing the elimination becomes multiply equation 1. Multiply equation 1 by a factor. Multiply equation 1 by a factor. How do you get the factor? It's very easy. Come here, since we are trying to eliminate x1 in equation 2, come here now. Where's the coefficient of x1 here? The coefficient of x1 here is what? A21. Is A21. So for you to get the factor now, for you to get the factor that you're going to multiply equation 1 with, it becomes A21 divided by the coefficient of x1 with, remember we are trying to eliminate equation 2 and what? Eliminate x1 in equation 2 using equation 1. So for us to do it now, the factor that we are going to use is the coefficient of x1 here in coefficient of x1 in equation 2 divided by the coefficient of x1 in equation 1. For you to get the factor, it becomes the coefficient of x1 in equation 2 divided by the coefficient of what? X1 in equation 1. Use it to multiply equation 1. Use it to multiply equation 1. How do you do it? To get the factor, alright, I said that the coefficient of this is divided by this. So therefore, alright, to eliminate x1 in equation 2, the factor we are going to use is A21, that is coefficient of x1 in equation 2 over the coefficient of x1 in equation what? 1 to multiply equation 1. Use the factor A21 divided by what? A11 to multiply equation 1. Now, why are we multiplying by this factor? We are multiplying by this factor because we want our x1 to have the same coefficient so that we will be able to eliminate it. So if we use this now to multiply our equation 1, we are going to have A21 all over A11 times, let me use bracket, in bracket, A11 x1 plus, use it to multiply the second one, A21 all over A11 in bracket, A12 x2 plus A21 all over A11 in bracket A13 x3 is equal to A21 all over A11 multiplied by, we also use it to multiply the right hand side, which is your what? Your B1. So if you do this, you can see that A11 will cancel A11 from here. If A11 cancel A11 from here, we are going to have A21 x1 plus, here we are going to have A12 A21 all over A11 x2 plus, here we are going to have this times this to give us A13 A21 all over A11 x3 equal to A21 B1 divided by what? A11. Now we have a new equation. So from here now, perform elimination. Remember, we are trying to eliminate x1 from here, this particular one here. We are trying to eliminate this. Now, to eliminate this now, you can see that since we have used the factor A21 over A11 to multiply our equation 1, we have gotten a similar number that is the same thing with what we have here. That is A21 x1 and what? A21 x1. So from here now, we will be able to what? Subtract the both of them. So let's do that. Remember, what is our equation 2 that we are trying to eliminate? Equation 2 is A21 x1 plus A22 x2 plus A23 x3 equal to B2. Alright? Now, what is the new equation we got? The new equation is A21 x1 plus A12 A21 all over A11 plus, okay, here we have x2, sorry, plus A13 A21 all over A11 S3 equal to what? A21 B1 all over A11. If we subtract A21x1 minus A21x1, this will what? Cancel out. Alright? Now if we subtract this from this, let's say that since this is at A22, let's call it, if we subtract this from this, since it's at A22, let's call the answer A22 prime. If we subtract this from this, right, we know that we're going to have a number, an answer, right? Let's call that answer A22 prime. If we call it A22 prime, this minus this will now give us A22 prime. Remember, x will be there, x2 plus minus this from this, let's call it A23 prime, x3 equal to minus this from this, let's call it B2 prime. Now let's call this equation 3. Let's call this equation 3. So if you have any question, just go to the comment section, type your question, or you can also send me a message on WhatsApp. I will reply to your question. Now that we've gotten this, the next step now, remember, if you look at this equation now, we have successfully eliminated what? X1. This equation has started from x2, x3. Now the next step now is to eliminate x1 also from equation 3. Eliminate s1 from equation 3 using equation 1. So for you to eliminate s1 from equation 3, it's also the same step with what we have. All you have to do is to get the factor. I told you how to get the factor. To get the factor, use the coefficient of x1 here. Use the coefficient of x1 here to divide the coefficient of what? X1 here and multiply equation 1 by that what? Factor. So let's get the factor. Let's get the factor. The factor becomes, let me write it, to eliminate x1 in equation 3, to eliminate x1 in equation 3, use the factor A3, remember coefficient of this over coefficient of this. So what is the coefficient of this is A31 all over A11 to multiply equation 1. Now let's use this now to multiply equation 1. If we use this to multiply equation 1, we are going to have A31 all over A11 in bracket what? A11 x1 plus A31 all over A11 in bracket A12 x2 plus A31 all over A11 in bracket A13 s3 equal to A31 all over A11 in bracket what? B1. If this multiply, A11 cancel A11 from here, we are going to have what? Going to have A31 x1, all right? Plus, here we are going to have A12 A31 all over A11 s2. Plus, here we are going to have this times this A13 A31 all over A11 x3 equal to, this will give us A31 B1 all over what? A11. Now since we have this now, the next step is to this to perform the elimination. Remember, we're trying to eliminate this S1 from here in equation 3. So the next step is perform elimination. To perform the elimination, now what is the equation I try to eliminate x1 from? With this equation. So bring the equation here. Equation is A31 x1 plus A32 x2 plus A33 x3 equal to what? B3. Now look at the equation we formed now. We can simply just put it here to get A31 x1 plus A12, A13, A12, A31 all over A11 X2 plus A13, A31 all over A11 S3 equal to A31 B1 all over what? A11. The next step now, elimination, subtract. If we subtract A31 X1 minus A31 X1 will give us what? 0. So this one is that. If we subtract these two now, we're going to have what? A32 X2 prime plus A33 A33 X3 prime. Then here we are going to add the value of a new value of A3 prime. Now let's call this equation. We have equation. Okay, yes, this one should be equation 4 because we have equation 3 there. So let's call this equation 4, call this equation 5. Now, the next step now is to, that is step 2, is to eliminate x2 in equation 3. Eliminate x2 in equation, in equation 5. Remember, we've already eliminated x1 from here and we got this equation. The next step now is to eliminate this s2 from here. Now, while we are eliminating s2 from equation 5, we perform the elimination with equation 4. Remember, when we eliminate x1 from here, perform the elimination with this equation and this. Then now, when we also repeat it from here, eliminate it from here, perform the elimination with this equation and this. Now, when we are going to eliminate s2 from here, you perform the elimination using your what? Equation what? 4. Perform the elimination using equation 4. Now, how do you perform the elimination? It's also the same thing. Get the factor that's going to multiply equation 4, and it will look like this. Get a factor that will multiply equation 4 to make it look like this. How do you get the factor? Also the same thing. What is the coefficient? What is the coefficient of s2 prime here? Is this. Now use that factor to divide the coefficient of s2 here. Then use the answer now to multiply equation 4. So we can simply say that multiply equation 4 by a factor. Now, what is the factor? So, coefficient of s2 in equation 5 over coefficient of s2 in equation 4. That is, coefficient of s2 is what? A32 prime all over what? A22 prime. Now, let's use this to multiply equation 4. If we use this to multiply equation 4, we are going to have A32 prime all over A22 prime in bracket multiply equation 4, that is A22 prime x2 plus A32 prime all over A22 prime in bracket A23 prime x3 equal to A32 prime all over A1 prime 22 is equal to multiplied by B2 prime. We are going to have this. So from here now, A22 prime, cancel out A22 prime here. We are going to have A32 prime x2 plus this multiply. We are going to have A23 prime over A22 prime, A32 prime x3 equal to A32 prime B2 prime all over what? A22 prime. So we are going to have this. Since we have this now, we now perform the elimination. Perform elimination. Performing elimination, since we are eliminating it, from here, it becomes A32 prime x2 plus A33 x3 equal to B3 prime. All right. Now, what was the new equation we formed to perform the elimination is this. So it becomes A32 prime x2 plus A23 prime A32 prime x3 all over A22 is equal to A32 prime B2 prime divided by A22 prime. Now from here, you subtract A32 prime x2 minus A32 prime s2. You are going to have what? 0. Now if this one subtract from this, you are going to have A33 prime x3 equal to B3 prime. We are going to have this. So from there now, if we say we should form our matrix, let's see if we have succeeded in getting 0 here, here, and here. Let's check. For us to check, we said arranging the matrix form. Arranging the matrix form, we are going to have what? A11 from equation 1, A12, and what? A13. Then we perform elimination where we eliminated this one from equation 2. From the elimination, we got here becomes 0, and we got A22 prime and what? A23 prime. And then we perform the elimination in equation 2. I will got, and on equation 3, sorry, I will got 0 here. Then we perform another one on equation 3. I will got 0 here, and we are left with what? This one here, which is what? A33 prime. Now, if you do this now, here becomes x1, x2, and s3 equal to what? B1. After we did this, we got B2 prime. Then at the end of this one, we got B3 prime. Now you can see that if you look at this, let's call this equation 6. If you look at equation 6, you can see that A3 prime x3. Okay, let's call this A3 prime. Sorry, I call this B prime. A3 prime x3 is equal to what? B3 prime. If we want to get the value of x3 here, you can simply divide both sides by A3 prime. A33 prime. This one will cancel this. So S3 here will be equal to what? B3 prime divided by A3 prime. So since we got this, you can simply substitute this answer into your what? Your next matrix here. And also the answer is from, if you substitute this into here, you are going to get the value of your S2. Then substitute the value of S2 and S3 into your what? Equation 1. So that is how you apply the Gauss elimination method. All right. Now let's look at example. Using Gauss elimination method. We are going to have 3 numbers of equation and use the Gauss elimination to find the value of x1, x2, and s3.